Hello everybody, welcome to my channel. Today I am going to discuss with you about how to find input resistance of a circuit if it contains some BJT, something like that, BJT. So generally we will use the small signal analysis, but it is a lengthy process, as we all know. All of us know that it is a lengthy process, so we can't apply it in gate, because within seconds we have to solve the problems. So here also we can calculate input resistance in within seconds. So for that there are some 5 figures we have to study. No need to study at all, only some 5 figures. Just go through it. By using that five figures, if you know that, then you can solve any problems. So finally this is that 5 figures: 1 2 3 4 5. Finally we will solve this problem. This is a great question only. So after solving this, you will also know that how to solve within seconds the input resistance. After this video, okay then let's start. So first of all, here what is input resistance? Input resistance is the resistance seen by the source or by the input, resistance offered to the input. So here resistance is here input is connected to the base terminal. So we are looking from the base only. So if you are looking from the base, then input resistance is equal to R pi. Input resistance is equal to R pi, and make sure that this is grounded. There is no resistance here in this part. Between emitter and ground there is no resistance, so our resistance will be R is equal to R pi. And in the emitter part, Rn is equal to, if you are connecting input at the emitter part, Rn will be 1 by Gm. Input resistance will be 1 by Gm. That will be the resistance seen by that source input. Here make sure that there is no resistor here. So this is the most general case. Here there is a resistor is connected between emitter and ground. So here input is connected to the base terminal, this figure. So how we can, so just consider in the first case, if there is no resistor here, there will be only R pi. R pi is think like this. R pi is connected between this emitter and this base and emitter. R pi is connected between this emitter and base. So here there is an extra resistor R, or resistance R. So what we have to do is this will be R pi is in series with this resistance R, which is multiplied by some factor which is called as 1 plus beta. So if you are going from base to emitter, if you are looking from base to emitter, the resistance will be this resistance will be seen by this input by 1 plus beta factor. So R pi will be R pi plus 1 plus beta into R. So this will be that thing. Similarly, in this case, here in base there is a resistance. So we are looking from emitter. If we are looking from emitter, resistance will be 1 by Gm without this resistor. If there is a resistor, we have to divide it by 1 plus beta. We have to divide the resistance by 1 by beta. That is shown here. That is 1 by Gm plus R by 1 plus beta. That is in series. That is 1 by Gm. There is a resistor here 1 by Gm, which is plus R by 1 plus beta. That is all. If you are going from base to emitter, multiply this resistance by 1 plus beta. If you are going from emitter to base, divide this resistance by 1 plus beta. And another case is here collector is shorted with the base. In this case, the input resistance and the input is then the input resistance will be 1 by Gm, and we are looking from emitter only, and we are looking from emitter in this case. So what is the input resistance? 1 by Gm parallel to R pi. This is just a load only, this is just a resistor only. Transistor means just a resistor in this case. So by this we can solve a problem. This is a gate question. Here there are input is connected to base of the transistor Q1, and the output is taken from emitter and is connected to the base and Q2. Here what is the input resistance? We have to calculate. For that input resistance, what we have normally do, we have to go from there. Here input is connected at a base, so there is a resistor R pi here, so R pi plus, normally we are going to do is R pi plus 1 plus beta into Re, not 1 plus beta into Re, because this is not the resistance, this is not the only resistance connected here. There is something this circuit also, here, this transistor circuit. Here we are looking from this transistor circuit. If we are looking from this transistor circuit, that will be some R pi 2. So R pi 2 is connected here, so this R pi 2 is in parallel with this Re also. So what we have to do is, first we have to look from here, that is R pi 2. R pi 2 is in parallel with Ra, that is multiplied by 1 plus beta. Here R pi 2 parallel to Ra multiplied by 1 plus beta, which is to be added, which has to be added from with the R pi 1. So the input resistance will be R pi 1 plus R pi 2 parallel to Ra into 1 plus beta. Here this is only a 2 transistor problem, but in gate there are 4 transistor problem, 5 transistor problem, and in last year there it was shown that some 31 transistors are given, some pattern, and it has to be just a parallel connection only, parallel connection of resistors only, because we have to think like transistor as a resistors only, then only we can solve that problems. So by using this technique we can solve any problem. Okay, then so if you have any doubt, then please comment. I will look all the comments and I will clear all your doubts. Just ask me through the comments. So if you like this video, then press the like button, otherwise dislike it. Then share this video to your friends also. Then finally kindly subscribe my channel, and the important and I will do another videos of how to find output resistance, similar to this, how to find output resistance and voltage gain of MOSFETs and this BJTs also, only similar to these techniques only. These techniques you won't see in any textbook. So kindly subscribe my channel. Thank you.